section 6.6, solving radical equations. Here are the steps that you'll use for this. So you are going to first isolate the radical. So steps easy as 1, 2, 3. You go number 1, you isolate the radical. That you probably would have done that already intuitively by this time. You isolate the radical. 2, if the radical is square root, what's the opposite of square root? Square, good. If it's cube root, you cube. So you take whatever power you need to get rid of the radical. So square or cube, etc., both sides. Because it's an equation, so you got to do it to both sides. Whatever you need to do to get rid of that the radical. And then something that you aren't used to always having to do is check for solutions that look like they work but they're not. Do you know what the word is for that? Extraneous. Because at the end of the day, anything you say works in an equation should work. And if it doesn't, you have to cross it off. So with radicals, they come up more often. Because when you square both sides, sometimes you add another solution. So you have to check. So we are going to do 4 examples here, all of different levels. So the first one is square root of 5x minus 9 plus 2, that's not under the radical, equals 13. So what should we do first? Isolate the radical, which means subtract 2, that's right. So we get square root of 5x minus 9 equals 11. And then step 2, since it's square root, we square both sides, so we can put in a different color. We can show that we're squaring. We're doing the same thing to each side like that. The radical and the square are inverse operations. They undo each other. So now we just have 5x minus 9. 11 squared is? Yes, it's not 22. 121. That means 11 times 11. And now we have a basic linear equation. Add 9 and divide by 5. And so we just want to double check that 26 works, is reasonable, and it looks like it is. 5 times 26 is about 130, minus 9 is 121, square root 11 plus 2 is 13. So it works, and that's that. Number 2, example 2, is this one's going to have an extraneous. Square root of x minus 6 equals x minus 8. Okay, so this is problem number 2. Problem number 2. Examples. These are examples. So problem number 2. Have we isolated the radical? Yeah, there's nothing else on this side besides the radical. So that step's already done. So what do we do to both sides? Square it. Yep. Now, be sure that you put parentheses to square the entire side, like that. You have to put parentheses around it and square the entire side, so the radical and the square disappear. There. So you just get x minus 6. And then, what technique do we have to use to multiply? This distributive property twice. This is, I'll just write it out since it's the first time this semester. That's really what it means, right? So you have to distribute the x and distribute the negative 8. So you get, if you distribute and combine like terms, you will get x squared minus 16x plus 64. Because you'll get 4 terms and then you combine like terms. Okay, so what kind of equation are we looking at here? Quadratic, right? The degree is 2, so we're going to get two answers. we have to do is combine like terms and get everything on the same side. Get it equal to 0, factor, and solve. So let's review that. Let's get everything on this side. So let's subtract x. We'll do two things at once. We'll subtract x and we'll add 6. We'll do the opposites of both of those. So we're left with 0 on one side. So I'm going to put it over here though, because usually it's easier if the 0 is on the other side. So this is 0, and we just combine like terms and we get x squared. What do we get when we add that? I heard minus 17x plus 70. That's right. Okay, so we can do a shortcut diamond problem. What multiplies to 70 and adds to negative 17? Yep, I heard negative 10 and negative 7 from Makai. And then you use the what property? The zero product property. Means when two things multiply to 0, either that's 0 or that's 0. It has to be. So you'd write two equations, either x minus 10 equals 0 or x minus 7 equals 0. And solving, you'd add 10. So you get 10 or 7, right? Now we have to check. So this is okay, we have to go back to the original equation. Okay, so let's try the 10. Ignore any, just look at the original. Okay, so 10 minus 6 is 4, square root is 2. Is that equal to 10 minus 8? Yep, that's fine. Let's try the 7. 7 minus 6 is 1, square root. Good. 7 minus 8? Negative 1. It doesn't work. See that? There's no way. The right side is 7 minus 8, and you get in the original. Don't ignore that it's squared. That we did that to solve it. So 7 minus 8 is a negative number, right? You can't take the square root and have the result be negative. So that 7, you absolutely have to cross it out. You have to show it at first, but then you have to cross it out. So the answer is only 10. That is the only thing that works there. We're going to do two more that are shorter but different. So example 3 is, any questions on that one? Okay, example 3 is x minus 1 raised to the 3/4 power equals 8. Yes, that's it. X minus 1 raised to the 3/4 power equals 8. So I thought we were solving radical equations. How is this like a radical equation? What did you learn yesterday when raising to the 3/4? Which one is the root? And which one is the power? Yeah, the root is the 4 and the power is 3. So there is a radical. If I rewrote it, I could rewrite it as a radical. But the easiest way to solve it is to go like this. There's a little trick. It's very simple. The easiest way is to raise each side to the reciprocal power of the fraction. So just take the 3/4, raise it to the 4/3 power, and you have to do the same thing to both sides. Okay, so whatever the reciprocal is, because when you multiply a fraction by the reciprocal, what do you always get? 1, right? Look, if you multiply straight across, you get 12 over 12, which is 1. And that disappears. Basically, it gets rid of it for us. So now we have a nice simple x minus 1 on the left side. And now this is what we learned yesterday. How do you evaluate 8 to the 4/3? You can actually do this in your head. You don't even need your calculator. So it means 8, it means raised, let's review from yesterday, it means 8 raised to the 4th power cube root, right? because the root's on the bottom and the power's on the top. But we can do these in any order. So, what do we want to do first? Do you want to do the cube root, or do we want to raise 8 to the 4th power? Definitely cube root. What's the cube root of 8? 2, and now 2 to the 4th is 2 times 2 times 2 times 2 is 16, yeah. So our final answer is 17. Does it work? 17 minus 1 is 16. Raised to the 3/4 is 8. Yes. And last one is the trickiest kind. Square root of x plus 15 equals 5 plus root x. Last one. So did we isolate the radical? Let's go through the steps. Well, it's impossible. Like, if I try to isolate, this is isolated, yes, this radical isn't, but if I subtract 5, it'll just go on the other side. That doesn't help, so we're done isolating it. So now we square both sides. Okay, so you square both sides, so you get, I'm not going to rewrite the original, so the radical goes away on the left side when you square that, and on the right side you have to be careful to square the entire side. So that's squared. Okay, so all I did was, I'll write it in words, square each side. Square each side. Okay, so now we have to be careful here to FOIL this out. And that's what is the interesting part, is that we have to FOIL something with a radical in it. But that's okay, we can do that. So, we'll do it one step at a time. First we'll distribute the 5 to both of these. We're going to distribute the 5. So 5 times 5 is? 5 times root x. If you multiply 5 times the square root of x, you just get 5 root x. You literally write them right next to each other. That's all you can do. It's 5 root x. And then root x times 5. Same thing, 5 root x. We could write root x 5, but we don't, that order is easy to mess up, so you put the number first. And then what's root x times root x? Isn't it just the square root of x squared? Okay, alright, so I'll write the square root of x squared, and what is the square root of x squared? Just x, that's right. So we'll, on the next step, we'll make it x. So now we have x plus 15 equals, okay, 25, and then we have like terms here. These are like adding like terms. 5 of something plus 5 of the same thing is how many? 10 of them. So 10 root x when you add those together. This is just x because the square root and the squared cancel. We're almost there. Now watch. What happens is these go away. I could just subtract x from each side. Those go away. We'll get the constant on the same side. We're going to isolate the radical like we did before. So subtract 25 from each side. So negative 10 equals 10 root x. Divide both sides by 10, right? We want to isolate the radical. So you have to isolate the radical again. What's the problem with that? Well, let's say we didn't. Wait, let's say you don't see a problem. Let's try and finish this. Then you would square both sides, right? This is why you have to double check your answers. So you would get x equals 1, and you would think that that might work, right? I wonder, does it? Let's try. We have to check. We have to double check. So does 1 work? Maybe it does, maybe it doesn't, but we better check. So 1 plus 15, square root is 4, right? And here we get 5 plus square root of 1. It doesn't work, does it? So there's actually no solution here. If you try it, you have to check. That's why you have to check. That doesn't work, so there's no solution. So this is a nice, like, extra credit type of question on a test. Not that you should assume the answer is going to be no solution, but